Hey guys, so this next lesson is still on quadratics, but it's now factored form. And so today we're mostly going to be going over just like basics of factoring. I am going to do at the beginning a little kind of overview of like what we'll eventually be getting to, but the meat of today is pretty much just like trying to remember how to factor. It is something that you've learned in Algebra 1, which I understand was a while ago, so I get it if you don't remember it. So I'm kind of going to teach it like you've never seen it. All right, here we go. Let's get started. Okay, so this first part is I'm just going to talk about what it means to solve a quadratic. So this is kind of like an intro to what we're going to be doing like later on in this section, but I just figured I'd show you what it means to solve a quadratic. And so when we solve a quadratic, we basically want to know where does it hit the x-axis. So the x-intercepts we've talked about, like if you look at this graph right here, -8 is one x-intercept, and it looks like 2 is the other one. So if you look in this bullet right here, those x-intercepts are called the solutions. They're also known as the roots of the graph or the zeros of the graph. And if in a week or so, or maybe longer, we're going to be doing a ton of work with finding the zeros and all of that. I just wanted to do a brief overview today. So we would say that the solutions to this quadratic, like I said, are -8 and 2, because it's where the graph hits the x-axis. What we're going to be doing in this section is we're going to be given the standard form, which we already know about. We're going to be given the standard form and be asked to find the x-intercepts. And how we do that is using the factored form. So everything that we're going to do today is going to look kind of like this. Each of these sets of parentheses, like this right here is one factor. This right here is another factor. Factors are numbers that multiply together, or terms in this case. Numbers or terms that multiply together to give you something else. So like this right here, this standard form is the same as this. I know it looks very different, but if we were to multiply this, and I'll refresh your memory on this in a minute. If you were to multiply this out like by FOIL or double distribute and combine like terms, you would get this. These are equivalent equations. And so what we're going to learn how to do today is take something like this in standard form and write it like something like this in factored form. So to start, I'm going to just refresh your memory on first factoring out a GCF. So a GCF is a greatest common factor. And basically what that means, it's the greatest number or term that is a factor of 2 or more other numbers. So basically, like if I want factors of 10, 2 times 5 is 10, or 1 times 10 is 10. And so I actually linked on Classroom. I put it in here just so you can see it, but I linked this factor chart on Classroom, and how this works is it has all the numbers from 1 to 100. I'm going to give you a hard copy of this when I see you in class, because you're going to reference it a lot throughout the year. But basically it gives you all the numbers from 1 to 100. So for example, 30, these are all the factors of 30. So all the different pairs of numbers that multiply to give you 30. So we will be referencing this a lot today. So the greatest common factor is the highest number that goes into both terms. And so when we factor, we want to take out the greatest common factor. We're basically like undoing distributive property. You'll see what I mean by that at the end. So the first thing we want to do is first like identify the GCF. And so to do that, I have these little bullets here, questions you want to ask yourself. What number divides evenly into 4 and 8? So they have 1 goes into both of them. Obviously that goes into everything, but you wouldn't really count that. 2 goes into both of them, and 4 goes into both of them. So 4 is going to be the number that goes into both of them. And then you want to look at, do they have any variables in common? Notice that this term has 2 x's. This is really written as, I can write it over here, 4 times x times x. That's really what that means, 4x squared. And then 8x is just 8 times x. So do they have any variables in common? Notice they both have 1x. So they have an x in common. So that means that if I were to identify the GCF of these two terms, it would be 4x, because 4x divides evenly into both of those terms. So that's the first thing you do, is identify the GCF. Next, you write the GCF outside a set of parentheses. So like this. Remember I said that taking out a GCF is like undoing distributive property. So remember, distributive property is you have a set of parentheses with a number in the front, and then you multiply it through. We're like undoing it. We're taking out what we multiplied by. And now inside the parentheses, you want to write, what would I multiply 4x by to get back to 4x squared? I already have a 4, so I don't need that, but I do need another x. And so notice that 4x times x would give you 4x squared. And then we want to think about 4x times what would give me 8x? Well, 4 times 2 gives me 8. We don't need another x. And so that would be your answer. And as a way to check it, if you were to distribute this 4x to both of those terms, you would get 4x squared plus 8x. And so that's your final answer. 4x was the GCF, and then x plus 2. So this is what it looks like to factor out a GCF. You have a term or a number out in the front, and then you have a set of parentheses with some more terms in numbers. And again, as a way to check it, you could distribute and multiply it through, and you should get back to the original. Come on. Okay, so we're going to do a couple more examples of finding a GCF. So number 2, we have 10x squared minus 15x minus 5. So we want to think about the highest number that goes into all three terms. It's going to be 5. Then you want to think about, do they all have a variable in common? Well, this one has 2 x's, this one has 1, this one has none. So they actually don't have a variable in common. So 5 is the only GCF. It's just 5 by itself. So now we're going to put that outside a set of parentheses, and we're going to think about 5 times what gives me 10x squared? Well, I need a 2 because 5 times 2 is 10. And then I also need the x squared because I didn't take out any x's. Now think about it. 5 times 2x squared, does that give us 10x squared? It does. Now 5 times what gives me negative 15x? It's going to be negative 3x because 5 times negative 3x is negative 15x. And then lastly, 5 times what gives me negative 5? Negative 1. So that would be your answer. Again, you could distribute it to get back to your original, but that would be your final answer. This last one has some x's and y's, and so that's okay. Sometimes you might have some x's and y's. Sometimes your GCF may even be more than one x. I can show you one of those too. So we have 12, 9, and 6. So the highest number that goes into all three of those is going to be 3. Let's see if they all have an x in common. Notice this one has 2 x's, this one has 1, this one has 1. So at a minimum, they all have at least one x. How about y? This one has 1 y, this one has 2, this one has 1. So again, at a minimum, they all have at least one y. So 3xy would be your GCF because each term has a 3 you could take out, each term has an x, each term has a y. So then you do your open parentheses. 3 times what gives me 12? It's going to be 4. X times what gives me x squared? X. And then y times what gives me y? 1. So we don't need to put that because we don't need another y. So if we put another y here, y times y would give you y squared, and we don't want that. Okay, let's keep going. So now we have, this is minus, so just put the minus. 3 times what gives us 9? That's going to be 3. We don't need another x because it's already here. So x would be like x times 1 gives us x. And then we do need another y because y times y would give me y squared, and that's what we want. Okay, let's do the last term. So it's minus 3 times what gives me 6? It's going to be 2. And then we have an xy already in the GCF, and we just need to get to xy. So we're going to stop at 2. If we added any other variables here, you would end up getting some like higher exponents. So there is the answer to this one. This is what it looks like. You're done here. We took out the GCF, and we figured out what we needed to put in the parentheses to get back to the original. So this is your final answer. The next thing we're going to talk about is factoring a trinomial when a is equal to 1. So let's talk about what that even means. Just as a little recap, I just wanted to talk about, do you remember when we would multiply 2 binomials like this? When you multiply 2 binomials like that, you get a trinomial in standard form. And so when we factor, we want to get back to that, just like at that example at the very beginning. So just to show you what I mean, let's take a look at this example right here. If I were to ask you to multiply those two values, if you guys remember the FOIL method or double distributive, you would do x times x is x squared. X times 5 is 5x. 7 times x is 7x. 7 times 5 is 35. And then you would combine these like terms and you would get x squared plus 12x plus 35. And see how that's a trinomial in standard form. So basically what we're going to be doing now is we're given this and we want to get back to this. So we're undoing the multiplication just like we did with factoring out a GCF. So if you take a look down here, this first example actually is this one. I just decided to redo it down here. If we were just given this and I asked you to factor it, this is what you do. You think about numbers that multiply to the last term, 35, positive, and you want to pay attention to the sign. So let me get rid of that so we can see the sign. So we want two numbers that multiply to 35 and also add to the middle term, add to 12. So basically multiply to C and add to B. And so what you can do is think about the factors of 35, numbers that multiply to 35. Now, if you don't know the factors of 35, take a look at the factor chart, find 35. Where is it? Here's 35. Those are the factors of 35. Of those factors, which ones add to 12? Well, 5 and 7. So those are your winning numbers because 5 times 7 is equal to 35 and 5 plus 7 is equal to 12. And so what you do is you write your factors in parentheses with an x because again, you want it to look like this. So you're going to have x plus 7 and x plus 5. I don't know why this plus sign isn't working. There we go. So that would be your final answer. I don't like how that looks. X plus 7, x plus 5. This is what your answer should look like. You should have two, it's called binomials. Binomials are two terms. This is one binomial. This is the other binomial. So you should have two sets of binomials in parentheses. So there's our first example. We have 4 more examples, and then you guys are going to try some. So next we have x squared minus 3x plus minus 10. Oh boy, long day. X squared minus 3x minus 10. So we want to think about numbers that multiply to 10 and add to negative 3. So let's think about factors of negative 10. We have 1 and 10. We have 2 and 5. And so since it's a negative, we have to be careful. Two numbers, in order for two numbers to multiply to a negative, one would be positive, one would be negative. So then you kind of want the difference between them to be 3. So obviously it's not going to be 1 and 10, it's going to be 2 and 5. And so you want to think about which one is negative and which one is positive, because remember, we want it to multiply to negative 10. So you match the higher number, which is 5, with the sign of the middle term. So our middle term was negative, so that means it's going to be 2 and negative 5, because 2 times negative 5 is negative 10. 2 plus negative 5 is negative 3. So once you get your numbers, you just put them in parentheses. X plus 2, x minus 5. And the order that you put it in doesn't matter. I could do the x minus 5 first or this one first. Doesn't make a difference. Okay. Next one. Whoops. Okay, so we have x squared plus 5x minus 36. And so again, we want two numbers that are going to multiply to negative 36 and are going to add to positive 5. And so you want factors of 36. So again, if you don't know the factors of 36, you look on the factor chart, but they're 1, 36, 2, 18, 4. Whoops, I skipped one. 3 and 12, 4 and 9, 6 and 6. So 36 has a lot of factors. Again, this one is a negative 36. So we need one positive and one negative in order to multiply to a negative 36. So basically, of these factors, we want to figure out if one was positive and one was negative, could we add them together to get a positive 5? So basically, we want to find a pair where the difference is 5. So that would be 9 and 4. And then again, you match the sign of the bigger number with the sign of the middle term. So this is going to be positive 9 and negative 4. So we have x minus 4, x plus 9. And again, 9 plus negative 4 is positive 5. 9 times negative 4 is negative 36. If you wanted to check your answer, you could multiply it out and combine like terms, and you would get back to the original. Next is x squared plus 3x plus 42. So we want numbers that multiply to 42 and add to 13. So again, take a look at your factor chart. If you don't know your factors of 42, right here. So we want them to multiply to 42 and add to 13. So the only ones that would add to 13, this is all positive. So they're just going to stay positive. We want just two numbers that multiply to 42 and add to 13 rather. It's going to be 6 and 7 because 6 times 7 is 42. 6 plus 7 is 13. So it's going to be 6 and 7. So you're going to have x plus 6, x plus 7. And now when they're all positive like this, you don't really have to worry about their signs because everything will be positive. Okay, and then this last one, again, we want them to multiply to 48 and we want them to add to negative 14. So let's look at the factors of 48. Right here, quite the long list. So this one, again, I already forgot what the number was. This one was multiply to positive 48 and add to negative 14. So let's think about that for a second. To multiply to a positive and add to a negative, they both have to be negative. And the reason for that is a negative times a negative is a positive, and a negative plus a negative is a negative. So we're looking for two numbers that they're both going to be negative that would add to negative 14. So let's see. It's 48. Oh, here it is. So go down the list. 1 plus 48 is 49. Nope, that's going to be 26. Nope, that's going to be 19. Nope, and so on. And you'd figure out that 6 and 8 would add to 14 and multiply to 48. And so for this one, they're both negative. So it's going to be x minus 6 and then x plus 8. Like that. Not plus. Oh boy. So for this one, it's going to be x minus 6, x minus 8. And so that's factoring. It can be kind of tricky. You really have to watch your signs. So just remember that if your last term is negative, that automatically means one of your numbers is going to be positive and one will be negative. Please let me know if you have questions. We'll do more of this next time. And yeah, again, email me if you have any questions, and have a great day.